So, solving equations by graphing and by factoring. And I guess we should say that usually we start with an equation. We factor it to get the factors. And then once we have the factors, we can set the factors equal to 0 to find the solutions, the roots, the zeros, the x-intercepts. All of those are the same thing. So that we've done before. That was the last worksheet we did. Was we start with an equation, we factor it, we set the factors equal to 0, and we find the solution / roots / zeros / x-intercepts. So let's do that for this first example. What are the factors of this expression? Another one with the lead negative. Again, there's a few people that factor with the negative in there. I think those people are crazy. I shouldn't have said that on video, probably. It's not my preference that you factor with the negative in there, but if you don't mind it and it doesn't bother you, it's certainly okay. I don't like it. I factor it out. I think it makes the factoring easier. So out comes the negative. Then, again, I think it's easier to factor what's left. Let's see. Got to be x and x. Got to be 3 and 1. It's a nice one. So x plus 3 and x minus 1 would make the double smiley face work. 3x minus x is 2x. 3 times negative 1 is negative 3. X times x is x squared. So there's my factors. The next line says, what are the zeros of the function? And it took me a year before I realized, oh wait, that's the same function. So we already had it factored. We are not going to solve it by graphing or by table. We are going to solve them or find them by setting that equation equal to 0. Right, so we set it equal to 0. Then we can find our zeros, solutions, roots, x-intercepts. This one's nice because we've already factored it. So negative x plus 3, x minus 1 equals 0. Set our factors equal to 0. The negative out front, sometimes that messes with people. But if you tried to set a negative equal to 0 like that, I don't even know what you would do with that. That doesn't make sense. So if there's an x out there, it matters. But if there's a 2 or a negative, then you couldn't set that equal to 0. So be careful if something's out front. Sometimes it matters, sometimes it doesn't. Basically, if it's an x, it would matter. But if it's not an x, it won't matter. Set the other two equal to 0. X plus 3 equals 0. X minus 1 equals 0. That is the step that you frequently skip, which is okay. X equals negative 3, and x equals 1. So I'm trying to get back to the big picture here. We started with an equation, we found the factors, and then we found the solutions, or the roots, or the zeros, or the x-intercepts. The next question is, what are the x-intercepts of the graph of, and again, it's the same thing. Well, we already factored the thing, so those are the x-intercepts. Negative 3, 0, and 1, 0. We're just trying to triple emphasize that solutions, roots, zeros, x-intercepts are all kind of the same thing. Thank you.
I think I read this wrong.
Yeah.
Have a good day.
Thank you. Next question, what are the solutions to this equation? Well, we already did this. Set the equation equal to 0. It's yes, it's still x equals negative 3 and x equals 1. So what we're trying to say here is that zeros and x-intercepts and solutions, those are all kind of the same thing. We write them a little bit differently because x-intercepts we write as points, but it's the same stuff. And I guess I should be careful. Factors aren't exactly the same thing, but factors lead to the zeros and the x-intercepts and the solutions, because those are all the same thing. This next question is new, but if we read it and think about it, it's not hard. Use the table to determine the location. I need to add something in there. I think we need to add approximate to determine the approximate location of the zeros of... This is now a new quadratic function, so we're stopped with that one that we did everything with. Okay, that's a lot of stuff going on. Perhaps some graphing would help. So -2, 9. Well, you know what? Let's back up a second. Zeros, that means where f of x equals 0. So probably the first thing we do is look on the f of x row to see if there are zeros there, and there are not. So that's why we said approximate, because I don't know where they are. But let's graph the points we have and see if that will help us. So -2, 9, -1, 1, 0, -5, 1, 2, 3, 4, 5, 1, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, -11, that's off the page. 3, -11 is almost off the page. 4, -9. Oh, I think we've crossed the axis of symmetry. We're now starting to reflect the cross here. 5, -5. 3, 5. 5, -5. 6, 1. 7, 9. 8, 19. Way off the page. So if I connect the dots here. Find the zeros. Okay, well, one of them's right there, and one of them's right there. So the best I'm going to be able to say is that there is a zero between. So look at my picture. What x values is that zero between? X between 0, between x equals 0 and x equals -1. And there's another one between, I've got to count, 1, 2, 3, 4, 5, and 6. Between x equals 0 and x equals 6. So that wasn't really that hard. Just plot the points and approximate the zeros, because that's as good as we can get. Before you turn the page, some of you eager beavers to get going here, is there a way I could have found that without doing the graph? What would you look for? Well, I'm looking for 0 in the y, but I don't see any zeros in the y. I'm closest to it. You're getting there.
Whenever if the y flips from negative to positive.
Yeah, if it goes from positive to negative, it's got to be in there somewhere. So when the y value changes from 1 to -5, then it had to go through 0 somewhere in there. And then same thing on this end. When the y went from -5 to 1, well, it had to cross through 0 somewhere in there. So the table makes it obvious, but if you understand what's going on, or excuse me, the graph makes it obvious, but if you understand the table and what it's giving you, you don't really even need the graph if you understand what all this point stuff is. Applications. Nope, not yet. Cross that out. Zero product property. You use this. We've used this already this year. We just didn't call it this. You know this. You just may not know that you know it. The zero product property says that if A times B is 0, the only way that can happen is if A is 0 or B is 0. Right? If you're going to multiply two numbers and get an answer of 0, one of them had to be 0. That's the zero product property. That's what helps us to solve by factoring. So more factoring. Let's see, this one's an easy one. X and X. 7 times 3 is 21. A positive 7 and a negative 3 would make a plus 4 in the middle. Why am I not done with this problem? There's a big issue for students is knowing, like, do I stop with factoring or do I keep going? How do I know I'm not done with this problem?
X equals minus 3 equals 0.
Right, it says solve, so I need to get to X equals something, probably two somethings. Okay, well here's the zero product property. I'm multiplying two things to be 0. So either the first thing is 0 or the second thing is 0.
You add the number
And then just move the number to the other side. X equals 3, X equals negative 7. Question B looks a little bit harder. On a couple of fronts. That's a negative 8 over there, and it's on the other side, so I need to move it over. Okay. I was thinking about moving it the other direction. But we'll plus 8. And here's where some of our friends like to mess with the negatives. I do not, so out comes the negative. To make it negative 2x and negative 8. So this one's a little bit harder with that 3 there. But the only factors of 3 are 3 and 1. Then switching to a pencil here because I don't know how this is going to work. Either 1 and 8 and 2 and 4. I almost certainly don't want the 8 across from the 3. That would make 24. If I put the 8 here and the 1 here, that's 8 and 3. That makes 5. That won't work. So I'm pretty sure it's the 2 and the 4. Did you already figure out where the 2 and 4 should go? The 2 and the 3 would make 6. So yeah, that's 6x and 4x. And if I want a negative 2 because that will make negative 6x. Positive 4 will make it plus 4x. 4 times negative 2 is negative 8. So it all checks out. And so am I done with that problem? No, because I have to solve. Here's where just switching the sign is going to mess some people up. That shortcut where they don't show the equal 0 step, and they're just like, oh look, it's got to be 3 and negative 7. That's fine. But when you get to 3x plus 4, I mean, it's still not hard, but it's an extra step that you're trying to do in your head if you're not careful. I'm going to subtract the 4 and divide by 3. So negative 4/3 and 2. Factor, set the factors equal to 0, and get your two solutions.
Whatever happens to the negative, like on the outside.
Oh, that's a good question. So again, sometimes if there's a variable out there, you need to set it equal to 0. But that's like a negative 1. And so negative 1, that doesn't equal 0, so I don't worry about that one. But if there was an x out there, I would have to worry about it. So numbers no, but letters yes.
-5. Would that count?
That wouldn't count because -5 doesn't equal 0. What do you want to do first on C?
Subtract the 28.
All right, subtract the 28 and the 12 over.
Subtract the 24 and then
I'm going to move those two over. That way my lead term stays positive. But if you wanted to move the 24x squared over, that would be fine too. Oh, then we're going to get to address your question here. I can factor out a 4. And in fact, yeah, let's just factor it out. Since it's an equation, I can divide both sides by 4. And then I don't have to keep the 4 out there. Let's see. This time I'm going to... So it's tricky because the front end has options now, right? I got to choose between 1 and 6 or 2 and 3. The back end has to be 1 and 3, so I'm going to go ahead and put those in 10. And then I'll switch to a pencil to figure out who goes where and which ones to use. Let's see. I don't think I want 6 across from 3. If I do that, that's not going to get me to 7. So I need to use the 2 and the 3. And again, if you can do a little math in your head, you can really speed this up, right? If I put the 3 across from the 3, that makes 9. 9 minus 2 is 7. So let's put the 3 across from the 3. And then I'm almost there. -3, that way I get -9. +1, that way I get a +2, and that way I get my -7x. That still equals 0. Oh, these are yuck, so let's take the time to set them equal to 0. I'll even show all the steps on this one. So 2x equals 3 and x equals 3/2. Factor, set the factors equal to 0. The hardest part is the factoring, right? Once it's factored, it's pretty easy from there. Most of you are pretty good at factoring by now. That's why we kept throwing you factoring problems. Feels like every day for the past week or so. Okay, last question is kind of a Jeopardy question. Right, watch the game show Jeopardy. In that game show, they give you the answer, and you have to provide the question. Well, it's like, here's the answers. What was the equation that led to those answers? So we have to work backwards. So I'm actually going to start at the bottom, so that when I finish, it'll look like a normal problem. So I'm going to work my way up. Okay, so if x equals 4, what does that mean? What factor did that come from? Good. X minus 4 equals 0, which means x minus 4 was the factor. Now the next one's a little harder because it's a fraction. You could multiply both sides by 3 to get rid of the fraction. So 3x equals -2.
3x plus 2.
So 3x plus 2 was the factor. Okay, so I've got the factors. I'm still not there yet because I want a quadratic equation in standard form. So what do I need to do with x minus 4 and 3x plus 2? FOIL it. So 3x squared plus 2x minus 12x minus 8. So 3x squared minus 10x minus 8. That's not an equation yet. So what do I need to do to make it an equation? I need to set it equal to something. And it doesn't really say 0 is fine, y is fine as well. Because when it says roots, that would mean you would set it equal to 0. So you could do y equals or equals 0, but you definitely have to have equal something to make it an equation. Okay, today's assignment is the next worksheet, but man, it goes pretty quick. Let's do the first couple together, because I think you're going to overthink how to do this. Use the related graph of each equation to determine its solutions. Well, remember, solutions, same thing as roots, same thing as x-intercepts, same thing as zeros. Well, if you know that, and it's already graphed for you, what's one of the solutions on that first graph? The x-intercepts. So x equals -3 and x equals 1. And that's it. It's like you're not factoring, you're not solving, you're not doing anything except looking at the picture. And so it's just a reminder or reiterate that the x-intercepts are the solutions to that equation. And so you don't really have to do anything. You just look at the graph and say what the x-intercepts are.
So what would you write them in the order pairs?
Because it asks for solutions, I would be okay with this. I would not be wrong if you did -3, 0, and 1, 0. Either one would be okay.
Right. Well, but like, which wording would you rather?
So x-intercepts needs to be an ordered pair.
That's the only one.
That's the only one. The roots, solutions, and zeros you could get by with saying x equals. Which is why I hesitate when I say these are the same thing. It's like, well, they're pretty much the same thing. So 2, 3, 4, 5, 6, those are pretty easy. 5's a bit of a tricky one. I mean, tricky in an easy kind of way.
For number 2, do we just put no solution?
So we could just say no solution. For number 5. Number 2 has a solution, though.
What?
Yeah, 3 does not. But 2 does, doesn't it?
No. I'm not so sure.
Wait, how do you know this is not a solution?
Because I'm looking for x-intercepts.
I mean, it does, like, the vertex does, like, right onto the x-intercept.
Yes.
But it should, like,
So that counts. So you're right, it doesn't cross the x-axis, but it touches the x-axis.
yeah.
And that's good enough. And yeah, you're right, number 3 is a no solution as well. So 1 through 6, pretty quick. 7, 8, 9, 10, those are the Jeopardy questions. So why don't you try number 7? Make sure we can go backwards. Number 7. I should hold up the Jeopardy music while you work on number 7. Surely you could finish it in the time that the Jeopardy theme song plays. Do 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 do. X squared plus 7x plus 10 equals 0. 7 through 10, and then the last 8 are more factoring, but solved by factoring. So you won't be done until you get x equals something. Right, so don't just factor. Make sure you factor and solve. In fact, maybe we should do number 16. Let's do 16. Cue the Jeopardy music. How would I... No, that's not a Jeopardy problem. What should I do to factor number 16? x and x minus 9. So let's set each factor equal to 0, including the x out front. So I get x equals 0 and x equals 9. And that's it. But sometimes the thing out front, if it's just a number, it doesn't contribute to the solutions. But if there's an x there, a variable there, then it does create a solution. Some of you already noticed that this page doesn't have a back. So with 15 minutes remaining, 20 minutes remaining, hopefully you can finish that before you go. Have an algebra-free week.